All right, let's have a look at the next problem now. So, um, for these guys under the advanced problem section, the first one I think is fairly standard. We've done problems of similar difficulty. The next two are more interesting problems, and they're definitely extra. You won't get anything this crazy on a test, unless you guys are familiar and have talked about the concept that I will go over in class. So there's a concept on factoring here. Um, if you guys have already done that in your class, then these two problems are fair game. If not, you shouldn't expect something like these two on a test. Okay, let's have a look at the first one. It says the first term of a geometric sequence is 3 and the fourth term is 24. Find the common ratio and the sum of the first 7 terms. So similar to the one above, the sum of the first 7 terms is equal to the first term, 3, times 1 minus the common ratio, which we don't know, to the power of 7 all over 1 minus r. Okay, so we have to figure out what R is, right? To figure out what S7 is. So we know that the fourth term is 24, so we're going to use exactly the same logic. We'll say 24 is equal to 3 times the common ratio we're trying to find. And this was the fourth term, so we'll do 4 minus 1. Let's solve for R. Let's divide both sides by 3, so 24 divided by 3, 3 times 8 is 24, so this is 8 is equal to r to the 3, and cube root on both sides. We get that 2 is equal to r, or r is equal to 2. Okay, now we're going to plug in the 2 here and go from there. So I'm going to erase these. We know the common ratio is 2, so r is 2. Okay, so S7 is 3, 1 minus 2 to the 7, all over 1 minus 2. Let's see what this comes out to. So we have 1 minus 2 to the 7. So that's 3 times negative 127, all over 1 minus 2, which is negative 1. So the negatives here cancel out, and we get that S7 is equal to, so that times 3, which is 381. Okay, so that's the answer for that problem. Let's have a look at problem 2. It says the sum of the first 2 terms of a geometric series is 20, and the first term is 5. Find the common ratio and the sum of the first 7 terms. Okay, so the sum of the first 2 terms is 20, and the first one is that. So we want the sum of the first 7 terms. So we're going to write down S7 is equal to the first term, which is what? First term is 2. Sorry, no, the first term is 5. So 5 times 1 minus the common ratio, which we don't know yet, to the power of 7 all over 1 minus 7. 1 minus r. Okay, so now we need to somehow figure out r, or figure out an expression for r, right? So now let's see how we can do that. To do that, we're going to write out 2 equations. First, we're going to write out an equation for that corresponds to this first sentence. It says the sum of the first 2 terms in a geometric series is 20. So S2 is equal to the first term, 5 times 1 minus r to the 2 all over 1 minus r. And I know S2 is 20. Okay, so that's our first equation. What else can we write down here? So let's see, the sum of the first two terms is 20 and the first term is 5. So we don't really need to write down anything else here, I guess. What we can do is take this, solve for r, plug it in here. Okay, so that's what we'll do. All right, let's see what this is going to come out to. First, I'll divide both sides by 5, so 20 divided by 5, that's 4, and that's equal to 1 minus r squared over 1 minus r. Okay, so what can we do from here? From here, what I'll do is I'll multiply both sides by 1 minus r. Okay, if we do that, we get, and I'm going to distribute here as well in one step, we're going to get 4 minus 4r is equal to r minus 1 cancels out. We get 1 minus r squared. Okay, this is a quadratic, right? Power of 2, r to the power of 2. How do we solve for quadratics? We move everything to one side, set it equal to 0, and factor. Okay, so I'll add r squared to both sides. So that's going to give me r squared plus 4 minus 4r equals to 1. Subtract 1 from both sides. We get r squared plus 3 minus 4r equals to 0. Rearrange just so that it's in order of the powers. 3 equals to 0. Okay, so we get this expression. Now, how do we solve this? We have to factor it. Okay, so what are two numbers that multiply to positive 3, add to negative 4? Well, those numbers are negative 3 and negative 1. So this factors to r minus 3, r minus 1. This is equal to 0. Okay. So solving this, if two things get multiplied by one another to give us 0, that means either r minus 3, the first term is 0, or the second term is 0. That's the only way for two numbers to get multiplied by one another and give us 0. One of them has to be 0. Okay, so that means either r is equal to 3 or r is equal to 1. Okay, so it looks like we can have two solutions here. So what we're going to do is pick one of them and go from there, right? First, we're going to make sure that both of the solutions work, and then we'll go from there. All right, so I'm going to erase all of this. We know that r is either 1 or 3. So r equals to 1 or r equals to 3. Let's do the math for r equals to 1 first. Okay, so what would our a be if r was equal to 1? Well, we know that the first term is 5. And so if r is equal to 1, the next term after 5 will also be 5, right? And the sum of 5 and 5 is not equal to 20. We know that the sum of the first two terms was 20, right? So this doesn't work. If r is 1, we won't get the right answer. Okay, let's check r equals to 3. So the first term is 5, the second term is 5 times 3, or 15, and the sum of the first two terms here does equal to 20. So this is the correct one. So we're going to use r equals to 3, and we will plug it into this formula. Okay, so S7 is equal to 5, 1 minus 3 to the 7, all over 1 minus 3. Okay, I will erase this and do the calculations here. Okay, let's see what this comes out to. 1 minus 3 to the 7. So that's going to be equal to 5 times negative 2,186 all over 1 minus 3, which is negative 2. So let's divide this by negative 2, also multiply by 5, and this comes out to 5,465. Okay, 5,465 is the sum. All right, this next one is extra interesting. We're going to use, I'll read through it in a second, but we're going to use exactly the same method as above, but the step where we factor will be a little bit more challenging. So number 2, actually, I said number 2 won't be, is something you guys won't see on the test if you haven't done factoring. But number 2 is actually something you could see on the test, because this type of factoring is the type of factoring you learn in grade 10. So question 2 would be fair game. Question 3 has what I was talking about. There's a factoring technique that we will learn later on. So if you guys haven't learned this in class yet, then don't worry about it. Okay, let's read through it. It says in a geometric sequence, the sum of the first 6 terms is 819, and the sum of the first 10 terms is 13,299. Find the common ratio on the first term. Okay, and by the way, the common ratio here was 3. Let's just write that down. All right, so we're going to do exactly the same thing. We want the sum of the first 10 terms. So S10 is the first term, which is sum of the first 6 terms is that, and the sum of the first 10 terms. So we don't know what A is. It'll be 1 minus R to the power of 10 all over 1 minus R. Okay, so we don't know A or R. We have to solve for A and R. Let's write out some equations. First, I'll write I will write out an equation that corresponds to this section. So the sum of the first 6 terms is that. So that means S6 is 819, and that's equal to some first term A times 1 minus some common ratio to the power of 6 all over 1 minus R. Okay, and the second equation I will write is about this. Sum of the first 10 terms is 13,299. So that's equal to A, 1 minus same common ratio, because we're talking about the same geometric series, but this time this will be raised to the power of 10 all over 1 minus R. Okay, we have 2 unknowns, A and R, and we have 2 equations, so we should be able to solve for A and R. Okay, what I'll do is I will solve for A in the top one and plug it in the bottom one. Okay, so to solve for A, I'll multiply both sides by 1 minus R. So we'll get this. So this was multiplying both sides by 1 minus R. And I'll divide both sides by 1 minus R to the 6. So we'll get 819 times this guy over 1 minus R to the 6 is equal to A. Now I'll take this and plug it in there for A. So we'll get that 13,299 is equal to 819 times 1 minus R all over 1 minus R to the 6. That's A, and then we have 1 minus R to this end. So we're going to copy down the rest of this as well, all over 1 minus R. Okay. So now we can cancel these 2 out. Now, when we cancel things out like this, we have to make sure that we aren't accidentally dividing by 0. So we would get a 0 here if R was equal to 1. The common ratio here isn't 1, just based on the way I've designed the question. But when solving problems in the real world, you have to make sure you keep track of that. So r can't be 1. But anyways, we cross those out. And let's simplify. So we have 13,299 is equal to 819. 1 minus r to the 10 all over 1 minus r to the 6. So next, I'll divide both sides by 819. So let's see, 13,299 divided by 819. And this is going to give me 341 over 21 after simplification. So I did the simplification as well. And this is equal to 1 minus r to the 10 all over 1 minus r to the 6. Okay, so we're going to remember this. I'm going to erase what we have. And we'll solve for r. Okay, so again, this next step, we're going to set up an expression and try to factor it. This is, if you haven't done it in class, this is all extra. So if you haven't seen this, don't worry about it. This is just meant to sort of challenge us a little. Okay, so I will cross multiply here, multiply those two and those two, right? So we'll get 341 times 1 minus r to the 6 is equal to 21 times 1 minus r to the 10. I will distribute. We'll do that here. So distributing these numbers, and we get 341 minus 341 r to the 6 is equal to 21 minus 21 r to the 10. I'll move everything to one side. So I'll subtract, I'll add 21 r to the 10 to both sides. 21 r to the 10 plus 341 minus 341 r to the 6 is equal to 21, and I'll subtract 21 from both sides. So we get 21 r to the 10. So 341 minus 21, that's 320. Minus 341 r to the 6. All right. And this is equal to 0 now. Now I'll just rearrange things so they're in order of their powers from largest to smallest. So the 6 plus 320 equals to 0. All right, so now we're going to have all of our focus on this expression. We need to solve for r here. And the way we would do this is by factoring. However, like I said, I haven't done a video on how to factor something like that. So I will, we're essentially going to do this by guess and check, but it's going to be a smart type of guess and check. So it's not completely random. So later on, we'll learn about something called the remainder theorem and the factor theorem. And those essentially tell us that if we are trying to factor something like this, or maybe not even factor, but solve something like this, to find a solution for something like this, other than just straight up guessing, what we can do is we can look at the factors of 320. And if this expression has an integer solution, so if r isn't a decimal, and we know, well, I can tell you guys r isn't a decimal just because I've designed the question so that r is a clean number, integer. So if that's the case, if we have integer solutions for r, we can expect that the solution will be one of the factors of 320 divided by one of the factors of 21. Okay, so it'll either just be one of the factors of 320 by itself, or one of the factors of 320 divided by one of the factors of 21. Okay, so first, the easiest one to check is just factors of 320. So factors of 320 are 1, 2, 3 should, or not 3, but 4 should work here. Let me just check. This is divisible by 2, and then 160, 80. Yeah, 4 works, and so on. And we can have plus or minus any of these, right? So we can have a factor of positive 2 or negative 2. I'll leave out the negative ones for now. Okay, and yeah, so we're going to start from the smallest one, plug it in, and see if any of them work. So if we plug in and we get 0, right, that means that's one of the solutions. So just by looking at this, if we plug in 1, we know we're going to get 21 here because 1 to the 10 is just 1, minus 341 plus 320. So is this going to work? Well, let's see. 20, we have negative 341 and 320. So that's going to leave us with positive 21. And we're going to add another, sorry, that's going to leave us with negative 21. And we're going to add another 21 to give us 0. So this one works. The very first one will work here. So I'm just going to double check that I did the math right. So r equals to 1 is one solution. Okay, we're going to see if we have any other solutions, just because like in the previous problem, we saw that we could have some issues with r equals to 1. So r equals to 1 might actually not work. Let's see if r equals to 2 works. So 21 times 2 to the 10 minus 341 times 2 to the 6 plus 320 equals to 0. So let me work through this. 21 times 2 to the power of 10. Okay, so that's 21,504 minus 2 to the 6 times 341. That's 21,824 plus 320. Let's see if this comes out to 0. So plus 21,504 plus 320. So this guy also works. So r equals to 2 also works. And we could have other solutions as well. Okay, so other r values might also work. I'm going to stop at r equals to 2, just because if r equals to 2 works, then we are good, right? We don't need to find all the solutions. It just wants one solution, one possible solution. So the reason I didn't stop after r equals to 1 is because, like I said, whenever you get a common ratio of 1, just like in the previous problem, there might be some issues where it doesn't actually work. So let's go ahead and test R1 and R2. So I'm going to erase this. And R1 and R2. So R equals to 1 or R equals to 2. And again, there could be other solutions. So let's do the math for r equals to 1 first. So actually, right off the bat, we can see that r equals to 1 won't work here. Why wouldn't r equal to 1 work? Well, because if we were to plug in r equal to 1 in our geometric sum formula, we get 0 in the denominator. And we can't have division by 0 in the denominator, right? Just to really prove this to you guys, let's do the calculations for r equals to 1. So we know that the sum of the first 6 terms was 819, and that was a 1 minus, or let's do it this way. We'll write this out. We'll do 1 minus r to the n, so that's 6, all over 1 minus r. So we can see that the r equals to 1 doesn't really satisfy this equation, right? If we plug in 1, we're going to get a 0 here. We're going to get a 0 there. So everything just goes to 0. But is it possible to have a series where the common ratio is 1 and the sum comes out to this for the first 6 terms? Well, we can think about that. If the common ratio is 1, that means all the terms are the same. So whatever your a term is, times 1 gives you the next term, times 1 gives you the next term, and so on. So if we add 6 a's together, right, because this was the sum of the first 6 terms, we're going to get 6a. So what would a be in this case? Let's see. It would be 819 divided by 6, which is 136.5. Okay, so this would be our a term. Now we're going to use this a term and the common ratio and see if the 10th term, or the sum of the first 10 terms, is equal to this guy. So like I said, if this is a and our common ratio is 1, the terms don't change, right? So the 10th term, which we're saying the sum of the first 10 terms should be this, it should just be 10a. Okay, so 10 times this. And if we do 10 times that, we see that we get 1,365, which is not equal to this. So that's why r equals to 1 doesn't work, right? If we test r equals to 1, that doesn't work. So we're going to use r equals to 2 instead. Okay, so we're going to erase this, use r equals to 2. Let's figure out the first term. How can I figure out the first term? Well, we know that we have this equation for the sum of the first 6 terms, 1 minus 2 to the 6 over 1 minus 2. So we get 819 is equal to a, let's see, what is 1 minus 2 to the power of 6? So that's negative 63. All over 1 minus 2 is negative 1. So here we get 819 is equal to a, and that's just 63. Divide both sides by 63. We get a is equal to 13. Okay, now just to make sure everything is good and r equals to 2 works, we're going to, using this a value, we're going to check to see that the 10th term, or not the 10th term, the sum of the first 10 terms is really equal to that. So if we do S10, that's equal to 13, first term, 1 minus 2 to the 10, all over 1 minus 2. And so let's figure out what this is. 1 minus 2 to the power of 10. So this is equal to 13 times negative 1023 all over negative 1. So S10 is, the negatives cancel out. 13 times that is 13,299. So we can see that with r equals to 2, everything works out, right? We satisfy both of our conditions for some of the first 6 terms and some of the first 10 terms. All right, now that we have found r and a, we can calculate the sum of the first 10 terms, or actually, it just wanted the common ratio on the first term. We have the answer for the sum of the first 10 terms, so we don't need to do this. We just needed this and this, which we already found. Perfect, so that's going to be it for that problem. All right, that's everything for today. Please let me know if you guys have any questions, and I can, if you put it in the comment section, I'll try my best to answer them. I hope you guys enjoyed this video, and I'll see you in the next one.